Hello. Here you will explore the relationship between quantities associated with individual electrons and the current flowing in a conductor. Look at the animation of electrons in a wire. Electrons are accelerated due to the potential difference across the conductor. They experience interactions with the ions in the lattice, which cause them to lose energy. Overall, they have an average velocity directed from negative to positive. This is called the drift velocity and is given by the symbol v. The unit for v is meter per second. In a time period of 1 second, what is the average distance that electrons will move in the conductor? So, recall that the velocity or the drift velocity is equal to the distance divided by time, and time is equal to 1 second, so the distance is equal to the velocity. d is equal to v in meters. What length occupied by electrons will pass a given point in the circuit? Also, it's v in meters. What volume occupied by electrons will pass a given point in the circuit if the cross-sectional area of the conductor is a meter squared? Yes, so the volume is equal to the area multiplied by the distance. So it's equal to A multiplied by V meter cube, since the distance is equal to the volume. Another question. How many electrons will pass a given point in the circuit if there are n electrons per unit volume? Yes, so it's equal to the number of electrons multiplied by the volume. It's equal to n multiplied by AV electrons. What charge will pass a given point in the circuit if the charge on each electron is E in coulomb? Yes, it's the number of charges multiplied by the number of electrons per unit volume, so it's equal to E multiplied by N multiplied by A times V coulomb. Remember that current I is the rate of flow of charge, which is the amount of charge passing a point in the circuit in 1 second. What is the expression for I in terms of the drift velocity? Yes, it's equal to the expression we have derived. It's N multiplied by A, V, E. The value of E doesn't change, and for a particular sample of a given conductor, N and A are constant. Let's use the slider to vary the current through the circuit. What happens inside the conductor if the current through it is increased? Yes, the drift velocity v increases. In fact, it increases in proportion to the current. The value of v is typically a few millimeters per second, around 10 to the power minus 3 meter per second. That's all. Thanks for watching.